Hey guys, I know a lot of you have been nervous about the fourth exam, so I'm going to go through the practical exam in a series of videos. So hopefully if we don't get to your question on our review day, you can see it in one of these videos. So we're going to start, not going to do true and false because I know we'll get to those during the review day. So let's start at number 2, which is all these inverse trig functions, which I've written up here. Alright, and we want to find the values of these 3 inverse trig functions. So before we do that, let's try to remember what the trig functions actually say, so not the inverse ones. So if we're just looking at sine of x, alright, just looking at sine of x, we're going to put in some angle in the unit circle which we have drawn over here. Alright, so let's do that. So we're going to take this initial side is always a positive x-axis, and then we're going to take our terminal side and rotate it away from there until we get the angle we want. So let's do that angle there, and we'll call it, not that, alright, and let's call that angle alpha. And now we're going to look at this important point here where this terminal side hits the unit circle, and we're going to call the x-coordinate cosine of alpha. We're going to call the y-coordinate sine of alpha. Alright, so that's the quick definition of what cosine and sine are. We make an angle, find where it hits the unit circle, the x value is cosine, and the y value is sine. Alright, so if we look at our function sine of x, we're going to have this equal to some y-coordinate, abbreviated, on the unit circle. So what do? We plug in an angle. Alright, so this x here is some angle. The one we just used was alpha, and we get out some y-coordinate. Alright, cosine works the same way, but we plug in some angle and get out an x-coordinate there instead of the y-coordinate. So now let's look at the inverse trig functions. Alright, so we're going to look at sine inverse of x. Alright, well, the inverse is to say we're going to flip the inputs and the outputs. So now instead of inputting an angle like we did in the sine, we're going to input a y-coordinate in the sine inverse, and we have to get out the opposite. So before we plugged in an angle and got out a y-coordinate, now we plug in a y-coordinate and we get out an angle. Alright, so that's the general idea of the inverse trig functions. We're just going to switch what we normally did with the sine and cosine, and the inverse is just switch what we did. Alright, so now going to the first problem. Let's look at that. Alright, so we're going to find sine inverse of the square root of 2 over 2. So again, like I just said, the square root of 2 over 2 is going to be a y-coordinate. Alright, so we're going to find sine inverse of the square root of 2 over 2. Alright, so let's go look at the unit circle again. Let's just say we're using this angle here, say here, and we knew the y value was the square root of 2 over 2. But the problem from the start is that this point here has a y value of the square root of 2 over 2, and so does this point here. Alright, so this is some x value and square root of 2 over 2. Alright, but when we're talking about sine inverse, we restrict the angles we're talking about. So instead of having this whole circle to look at, we're only going to restrict our attention from negative pi over 2, so all the angles that we rotate down this way, up to positive pi over 2, so all the angles we rotate up this way. So we don't have to worry about this point over here because it's not in the domain of the stuff that we're talking about. So now we have to find some angle. Alright, so again, we're going to get an angle out of this, because we're putting in this y-coordinate, we want to get out an angle. So the question that I kept writing on the board when we were learning this is what angle? Alright, let's call it alpha again, and it has to be in the range that we care about, so I just said we care about from negative pi over 2 to pi over 2. Alright, we want to know what angle in that range has, when we plug it into sine, we get out what we care about in sine inverse, or square root of 2 over 2. Because these two are inverses, if I plug in alpha into here, into sine, and get out square root of 2 over 2, then when I plug in square root of 2 over 2 into its inverse, then I have to get out alpha. Alright, so I have the chart written up here with our main 5 angles in the first quadrant and their sine and cosine values. Alright, so we know, for looking at this, for the square root of 2 over 2, we go across here, and we see that sine of pi over 4 equals the square root of 2 over 2. Alright, pi over 4 is in the range that we care about, so now we know that pi over 4 is the angle we're going to use. Alright, so we're going to have the angle pi over 4, it'll output the square root of 2 over 2. We switch those around, we put in the square root of 2 over 2 in the sine inverse, and we get out the angle pi over 4. Alright, so I'm going to write it up here. This one is pi over 4. Alright, so the positive ones in the first quadrant, tend to be a little bit easier because you can just use this chart up here. We wanted sine inverse of the square root of 2 over 2, so we just look at what angle in the first quadrant gave that to us. Alright. Well, now let's go on. The cosine inverses and negatives tend to be a little bit harder, so let's go on to C first. Alright. And we're going to find arc sine, which again is the same thing as sine inverse. Some professions use arc sine, some use sine inverse. So we're going to find arc sine of the negative square root of 3 over 2. And again, we're going to ask the same question: what angle in negative pi over 2 to pi over 2 has sine of some angle equal to this? Alright, so we have to find sine, some angle in between negative pi over 2 and pi over 2 that outputs negative square root of 3 over 2. Alright. But we're going to do that by just looking at the positive one first. So we're going to look at arc sine of the positive square root of 3 over 2. Alright, we're going to find that out, and from finding this out, we're going to find the negative value as well. Alright, so again, this is a positive value in the first quadrant, so we can just look at our table. We go to the square root of 3 over 2, and we know we had to put in pi over 3 to get that out. So if I go over to my table, or my picture of the unit circle over here, say this is pi over 3, alright, that angle there, alright, then we know we had to get out the y value of the square root of 3 over 2. So we know the y value there is the square root of 3 over 2. What we're going to do, if we have this y value here, and we flip it over the x-axis, which is the initial side of our angle, this point down here, so I flip this point straight down over the x-axis, alright, the x value won't change, and the y value will just be the negative of the y value of the point up there. Right. So we had this relation between these 2 points here. Well, I'm also reflecting this green line, alright, which is the terminal side of my angle. Alright, I'm reflecting that down, I still get that angle right there. Alright, well, if I reflect this pi over 3, here I rotate it up, so I got a positive pi over 3. To get to this green angle down here, I have to rotate down, or clockwise, and that gives me a negative pi over 3. So we have a negative pi over 3 for that angle there. Alright, so now, again, negative pi over 3 is in the range that we care about, from negative pi over 2 to pi over 2. We plug it into the sine function, we get out this y value here, negative square root of 3 over 2. So now we know that this has to be the negative pi over 3. Alright, so again, I'm going to write this up right here. This is negative pi over 3. Alright, so now on to the last question, the cosine inverse. Alright, so we're going to find cosine inverse a negative 1/2. Alright, so let me erase all this. And again, we're going to do the same type of thing. We're working with the negative values. We're going to look at the positive values first. Alright, so we're going to look at cosine of just 1/2 first. Or cosine inverse of 1/2. And again, we can use this chart. When we want to plug an angle into cosine and get out 1/2, we plug in pi over 3, alright, into cosine and we get out 1/2. So we know cosine inverse of 1/2 is pi over 3. Now with cosine, we restrict the domain to 0 to pi. So if we're trying to find cosine inverse negative 1/2, alright, we need to know what angle alpha, and instead of negative pi over 2 to pi over 2 that we use for sine, we're going to use 0 to pi for cosine, and we know what has cosine of alpha equal to the thing that we care about, which is negative 1/2. We're going to do the kind of the same idea we use for sine, but it won't work out quite as nicely. So we know, say, now this angle here, I was still pi over 3 because we know that. Alright, but let's write it in blue. So this angle here is pi over 3, which gives me here an x value we know of 1/2. Alright. We're going to do the same thing with the reflection. I'm going to reflect this over the y-axis, so now the y value is going to stay the same, so this will still be the square root of 3 over 2 for the y value, but the x value would just become the negative, so now this is negative 1/2. Alright. Just reflect over the y-axis, the x value just goes negative and the y value stays the same. Alright, well that's exactly what we want. We want cosine inverse to be negative 1/2, so we want to know what angle, let's do it in red, is going to hit that point there and have the x value of negative 1/2, which means the cosine of this angle here, this big angle there, alright, is going to give us negative 1/2. Alright, so the way we're going to do that is we're going to see that we have the straight angle here. Alright, we know the straight angle is pi. Then we took this pi over 3 and reflected it, so this angle made with the negative x-axis right there is negative pi over 3. Well, just pi over 3 actually. Alright. So that's just pi over 3. Alright, well, we care about this red angle here. We have the straight angle is pi, and this little bit is pi over 3. So if we take the straight angle and get rid of this little bit, then we'll get the angle that we care about. So we're going to take pi, alright, subtract the pi over 3, alright, and that's 3 pi over 3, which is the same thing as just pi, minus pi over 3, which equals 2 pi over 3. Alright, so this red angle here, which is the straight angle minus pi over 3, is 2 pi over 3. And now if I plug 2 pi over 3 into cosine, I get this point here, and I'll take the x value, which is negative 1/2. So I know cosine of 2 pi over 3 equals negative 1/2. Alright, so that's the first step. I found an angle whose cosine is what I want it to be. And now the next thing is to make sure it's in the range I care about, but 2 pi over 3 is bigger than 0 and less than pi, so it's in the range I care about. So now I actually have my answer that I plug 2 pi over 3 into cosine and get out negative 1/2. So now I plug in negative 1/2 into cosine inverse and have to get out 2 pi over 3. Alright, so now we also have this answer at the top, 2 pi over 3. Alright, so that's how you're going to do all your inverse trig functions. This question right here is going to come up a lot. Alright, we're going to find an angle in the range you care about. So again, the range for sine inverse was negative pi over 2 to pi over 2, which was this half of the circle. Alright, and the range for cosine inverse is 0 to pi, so it's the top half of the unit circle. Alright, so make sure you're in the right range for your answer, and you just want to find an angle that you put in and you get out what you cared about here. So we want to find an angle that we put in and we get out the negative 1/2 because we're trying to find cosine inverse of negative 1/2. Alright, and if it's a negative value, you're going to have to find the positive value first. Alright, and then if it's sine, you'll reflect it over the x-axis, alright, which basically means you're just going to put a negative sign on the angle. Alright. And if you're looking at cosine, you're going to reflect it over the y-axis. What you're going to have to do is take pi, alright, subtract the angle that you found for the positive one, and it'll give you the bigger angle here, which is actually what your answer is going to end up being. So that's how you do the inverse trig functions and how you find their exact values. Alright, so that's number 2, all 3 parts. So let's go on to number 3. So for number 3, we want to find sine of arctan of x. So again, we just looked at inverse trig functions. Alright, and here we have arctan rather than arcsine or sine inverse or arccosine, cosine inverse. Alright, but here, instead of an actual value like the square root of 2 over 2 or 1/2 or any other values, we just have an x. Right, so we want to figure out some algebraic expression that's equivalent to this. Alright, so the final answer will have more x's in it. We're not going to find an exact value for this. Alright, so the idea, the first thing we want to do whenever we see one of these two compositions with just a variable on the inside, we're going to make a right triangle. Like that. Alright, so let's make a right triangle. Alright, and we're going to label one of the angles, so you can pick this one. I'm going to pick this one down here. We're just going to call that angle theta. Alright, so that's a theta. Alright, and now we have to use SOHCAHTOA and our information about the inverse trig functions in order to find some information about this triangle. Alright, well, we know in our inverse trig functions we put in some coordinate, so with sine inverse and cosine inverse we put in the y's and x values. Arctan will be the y values over the x values. Alright, but now instead of thinking about it that way for this problem, we're going to think about it in terms of SOHCAHTOA. Alright, so originally with tangent, we know that tangent of an angle alpha in a right triangle, alright, well, it's TOA, so it's going to be the opposite side here over the adjacent side here. Alright. So that's another way we can think about tangent when we're talking about a right triangle. Alright, well, if we're talking about arctangent, we're just going to flip these just like we did before. Arctan of x, alright, equals, alright, so before we put in the angle of the right triangle and we got this ratio of the opposite side of the adjacent side, so here we're going to input this piece here. What we're inputting is actually the opposite side of the adjacent side of the right triangle, and we're going to get out some angle. I guess we'll just call it alpha. Alright. So now if we're looking at our actual problem, we're going to set at the beginning, we're going to set theta, which is the angle that we picked in here. We're not going to change this angle throughout the whole process, but we're going to set this angle, because we know we get an angle out of arctan. We're going to set this angle equal to arctan of x. Alright. And then this is going to convert this problem just into sine of theta once we figure out how this is related to our right triangle. So the important thing, again, we're putting in the opposite over adjacent side of our triangle, and we're getting out this angle alpha. So in order to get out this angle theta that we're talking about, we inputted this ratio. So here we're going to have x is equal to the ratio of the opposite side over the adjacent side. Right. And there's an easy way to make x equal to this rational. We're just going to say x is the same thing as x over 1. So we're putting in this ratio of x over 1 into arctan. We have to get out this angle theta. Alright, so in our right triangle, we need to make sure our ratio of the opposite side of the adjacent side is x. So we're going to make this side here, which is the opposite side from our angle, x, and the adjacent side we're going to make 1. Alright, so now this problem up here simplifies down to just sine of theta. Because we got all the information we could out of arctan of x. We know if we plug in x over 1, we get out this angle theta. So we're going to place this piece here with theta. Alright, so now we just need to find sine of theta. We know sine, according to SOHCAHTOA, sine of theta is going to be the opposite side over the hypotenuse. Alright, but we've run into a problem because we do have the opposite side, that's just x, but we don't have the hypotenuse yet. But we do have a nice theorem about right triangles, the Pythagorean theorem, that says if we take the two shorter sides, the legs, and square those, we're going to get the length of the hypotenuse squared. So we're going to take this side 1 and square it, this side x and square it, and we have to get the hypotenuse, which for now I'm just going to call h squared. Alright, so we're going to solve for how long this hypotenuse has to be. Alright, we're just going to take the square root of both sides. H equals plus or minus the square root of 1 plus x squared. Again, 1 squared is just 1, so I don't rewrite that. Alright, so now we know this hypotenuse up here is just plus or minus the square root of 1 plus x squared. And now our final goal again is to find sine of this angle theta now that we know all three sides. So we're going to go back to the middle of the page here. We have sine of theta equals opposite of hypotenuse. The opposite side from theta, again, don't change what angle you're talking about. We're sticking here with this theta. The opposite side is x. Right. And the hypotenuse we know is plus or minus the square root of 1 plus x squared. Alright. And it's fine in this case to leave the radical in the denominator, so our final answer, we're just going to box it right here, is that this equals x over plus or minus. So the plus or minus can come out front. We get plus or minus x over the square root of 1 plus x squared.